Okay, so this is our problem set number 3 for the torque. A uniform beam of length weighs 200 Newton and holds a 450 Newton object as shown in the figure. Find the magnitude of the forces exerted on the beam by two supports at its end. So we definitely want to find the F1 and F2, and this is the support. So, the given, we have here the force of the weight beam is 200 Newton, and at R, which is pivot from F2, so we will make this as our pivot, the F2, since this is our support. We have L over 2. Okay, so this is the 200 Newton, the distance is L over 4 plus L over 4, that is simply 2L over 4, and that is L over 2. And the weight of that object is 450 Newton. This is the object at R pivot from F2, which is L over 4. The required is simply the F1 and F2. So our equation would be torque is equivalent to force perpendicular multiplied to distance coming from the pivot. And the solution is summation of torque is 0 since this one is not moving. So let's solve first for F1. We all know that the summation of torque is, here it is, so F1 times the R for F1. We have also the force of the weight of that beam multiplied to R, and the force or the weight of the object multiplied to the R. Okay, now, so basically, we'll label this as our pivot. We have to determine if it will turn clockwise or counterclockwise. Now, for F1, so if this will be our pivot, it will turn on clockwise. So therefore, F1 would be negative. Okay, so for this portion, the 200 Newton, and this is the pivot, it will turn into counterclockwise. So therefore, the sign would be positive. And for that weight of the object, it will turn also counterclockwise. So therefore, we could expect that it is positive. Okay, so we are now ready to plug in all our values. Okay, so 0 is equivalent to negative F1, which is we don't know, multiplied to the distance from the pivot. So the R here, as we all know, the value for that is simply L over 2 plus L over 4 plus L over 4. That's simply equivalent to L plus 200 Newton multiplied to L over 4 plus L over 4, that is simply equivalent to L over 2, plus 450 Newton multiplied to L over 4. So 0 equivalent to negative F1 multiplied to L plus 200 Newton multiplied to 2L over 4, or simply 0.5 plus 450 Newton multiplied to L over 4. So F1 multiplied to L is equivalent to 200 Newton multiplied to 0.5 plus 450 Newton multiplied to 0.25 L, and that's it. Okay, now, we simply transfer this F1 to the other side. That would become positive. That is 100 Newton times L plus 112.5 Newton times L, and that is equivalent to 212.5 Newton multiplied to L. Now, dividing both sides by L, could simply cancel that. Okay, cancel that L, cancel, and therefore, our force 1 is equivalent to 212.5 Newton. But again, we have to round it off into 3 significant figure. The answer is 213 Newton, rounded to 3 significant figure. Now, let's solve now for F2. So this is again our figure, but this time, let's make F1 as our pivot. So we have here the summation of torque is equivalent to F2 multiplied to R, And then the F weight, beam, which is, of course, we all know that's 200 Newton multiplied to R, and then the F weight of the object, okay, which is 450 Newton multiplied to R. And then therefore, we try to determine first if it will turn clockwise or counterclockwise so that the sign would be positive or negative. So we have here the F2 would turn on counterclockwise. So therefore, that is positive. For the weight of the beam, that will turn in a clockwise direction, so we can expect that is negative. And for the other one, we have clockwise, which is negative in direction. And therefore, plugging on all the values, we have 0 is equals to F2 multiplied to L2 plus L4 plus L4. L over 4 is simply equivalent to 1 plus 200 Newton, which is for the weight of the beam, multiplied to distance of the pivot, that is L over 2. And this 450 Newton times L over 4 plus L over 2, that is simply equivalent to 3 over 4 L. So we have here 0. By simply performing the mathematical operations, we have here F2 multiplied to L, and then 200 Newton, that's L over 2 plus 450 Newton, 3L over 4. And then transferring this to the other side, and then performing the operation. So we have here F2 multiplied to L is equivalent to 100 Newton L plus 450 multiplied to 0.75 L. So therefore, F2 is equivalent to 100 Newton times L plus 337.5 Newton times L. And then therefore, F2 is equivalent to 437.5 Newton times the L. Dividing both sides by L, and that would make the same number. So cancel the L, cancel, cancel, and then therefore the answer is 437.5 Newton. By the way, the L here is being cancelled out. Okay? So the answer here is 438 Newton, rounded off to 3 significant figure. Now, there's an alternative solution for finding the F2 since we already find the F1 from the problem that we have. We simply draw a free body diagram, and we all know that the summation of Fx is 0. Why? We don't have any x component. So the summation of Fy is also 0, simply because it will not be moving up and down. So that object is not moving. So according to Newton's first law, the object at rest, the sum of all its forces is 0. So we have this force component, which is F1. We also have the other component, which is F2. So we simply have summation of Fy is equals to F2 plus F1. And the other component would be the weight of the beam, which is, of course, will have a sign of negative because it is downward. And the other one, the weight of that object, which is also simply negative. So plugging this in, we have the weight of the beam and then the force, which is the weight of the object. Summing it up, we have 0 is equals to F2 plus 212.5 Newton, which is the value of our F1. We had already solved it. And 200 Newton for the weight of that beam, which is negative 200 Newton, plus the weight of that object, which is negative 450 Newton. So F2, that is 437.5 Newton. That's simply 212.5 minus 200 minus 450 Newton. And then therefore, transferring this to the other side, or transposing this to the other side, we have F2 is equivalent to 437.5 Newton, which is the same answer from the previous technique that we had.